Good morning students. Today we are going to deal our sixth module and the first topic is regarding interpolation. The word interpolation means we are going to find unknown values which are in between the known values. That is, using the known values we are going to find the values of unknown values. And here we have derivation of shape function or interpolation function for constant strain triangular element. You will be unfamiliar with the term constant strain triangular element. Constant strain triangular element is one of the type of triangular element. Triangular element is basically of two types: constant strain triangular element and linear strain triangular element. In case of constant strain triangular element, we will have three nodes, and in case of linear strain triangular element, we will have six nodes. And as I already mentioned you, constant strain triangular element have three nodes, and these are the nodes 1, 2 and 3. Since we are having three nodes, the displacement will be of 6. We have already studied in the previous class that is in fifth module that each node will have 2 displacement. So if we are having 3 nodes, we will have 6 displacement, that is u1 v1, u2 v2 and u3 v3, and we are mentioning each nodes in coordinates: for 1 x1 y1, for 2 x2 y2 and for 3 x3 y3. And if we are writing the displacement in matrix form, we will get u1 equal to the displacement u equal to u1 v1 u2 v2 and u3 v3. And we know that the area of triangle, if the coordinates are given, area of triangle equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus s3 into y1 minus y2. We are removing the brackets. So half into x1 y2 minus x1 y3 plus x2 y3 minus x2 y1 plus x3 y1 minus x3 y2. And we know that the displacement matrix uxy equal to a0 plus a1x plus a2y. This we have already studied in the fifth module, and we are writing it in our matrix form. So 1xy equal into a0 a1 a2, and we have three nodes, so we are converting this equation in a small manner. So for first node u1 x1 y1 equal to a0 plus a1 x1 plus a2 y1, and for node 2 u2 x2 y2 equal to a0 plus a1 x2 plus a2 y2, and for node 3 u3 x3 y3 equal to a0 plus a1 x3 plus a2 y3. And we are combining these three, that is the nodes equation, the three nodes equation, and we are writing it in our matrix form. So u1 u2 u3 equal to 1 x1 y1, 1 x2 y2, 1 x3 y3 into a0 a1 a2. From here onwards, we have already studied the steps, that is in the previous in the fifth module. That is, we want to get the value of a0 a1 a2, so we are taking this matrix form into left hand side, so we will get A inverse, that is inverse of this specific matrix, that is u1 u2 u3 equal to into 1 x1 y1, 1 x2 y2, 1 x3 y3 inverse 1 a0 equal to a0 a1 a2. And we know that A inverse 1 equal to adjoint A divided by determinant A. That is, we can find each values. Determinant A equal to 1 into x2 y3 minus x3 y2 minus x1 into y3 minus y2 plus y1 into x3 minus x2. And we are removing the brackets. So x2 y3 minus x3 y2 minus x1 y3 plus x1 y2 plus y1 x3 minus y1 x2. And we are rearranging it. x1 y2 minus x1 y3 plus s2 y3 minus x2 y1 plus s3 y1 minus s3 y2, and this is a similar term, that is we are already seeing this in here, that is half area equal to half of this thing, and we can write this thing as 2 into a. So determinant a equal to 2 into area, and we already know how we can find an adjoint a, that is first we want to remove this and this, then x2 y3 minus x3 y2, x2 y3 minus s3 y2, then we want to remove the second a21 row and column, and want to write x1 y3 minus x3 y1 minus x1 y3 minus x3 y1, then we want to write we want to remove both of these, x3 minus x2, sorry, here this one, so x1 y2 minus x2 y1. After that we want to remove this row and column, so we will get y minus y3 minus y2, that is just remember plus minus plus minus plus minus plus minus plus. This will be the first term, and just remove and go forward, and final term will be x3 minus x2 minus x3 minus x1 plus s2 minus x1. So while removing the brackets and all, we will get x2 minus s2 y3 minus x3 y2. Here while going inside, we will get plus s3 y1 minus x1 y3, and here x1 y2 minus x2 y1, and here when going minus inside, y2 minus y3 minus y1 minus y2, s3 minus x2, x1 minus x3, s2 minus x1. So we will get the adjoint a's value. Therefore the value 1, this equation will become uxy equal to 1xy into u1 u2 u3 into 1 by 2a into this matrix, that is adjoint divided by determinant a. We got the value of a inverse, and we are substituting the value of a0, a1, a2 into this equation. And what we are doing is we are multiplying 1xy with this specific matrix, that is this matrix and this matrix. So 1 by 2a, 1 into x2 y3 minus s3 y2 plus x into s3 y1 minus x1 y, x into y2 minus y3 plus y into x3 minus x2. Similarly, this one into s3 y1 minus x1 y3 plus x into y3 minus y1 plus y into x1 minus x3, 1 into x1 y2 minus x2 y1 plus x into y1 minus y2 plus y into x2 minus x1, u1 u2 u3. So we are familiar with this also from module 5. If we are coming to a situation like this, we will get the value of shape function, and the shape function n1 equal to 1 by 2a into this whole term, that is x2 y3 minus x3 y2 plus x into y2 minus y3 plus y into s3 minus x2. Similarly, n2 equal to and n3 equal to, and we will have certain other equation, displacement u equal to n1 n2 n3 u1 u2 u3, u equal to we can write in u and y v term, n1 n2 n3 v1 v2 v3, and we are combining these two. While combining these two, we can write u equal to n1 0 n2 0 n3 0 0 n1 0 n2 0 n3 u1 v1 u2 v2 u3 v3. The 0 is coming in here because we know that the displacement function, that is the u term, won't go in v term, that is u means horizontal direction and v means vertical direction. So that is why the 0 comes, because since n1 the shape function is in here for v, for u there won't be any shape function. Now displacement will be there if vertical is acting, and no displacement will be there if horizontal is acting. That is why the corresponding terms are coming as 0. And these are the main equations, that is n1, n2, n3, and this one u equal to, this one are the two main equations. If you are having any doubts in derivation, please contact me. Thank you.